Thank you very much, Akka. Hi, everyone. Saying hi again, even though I think I talked to most of you. I'm super excited to be here and to share what we're doing in the research community when it comes to threat modeling. And my name is Engla Rencelj Ling, and I am currently doing a PhD at KTH. So just like Nadia, I wanted to just show who am I? Yes, it's a bit of an existential question, but to show some background, I did my master's at Uppsala University. I started that back in 2010. After that, I worked for a couple of years for Cisco Systems. You've heard of that, I hope. Yeah, some nodding heads. And there I was a systems engineer, so I was helping customers to decide how to build their networks, so wireless and routing and switching. Then I got bored of that and decided it was time to do some research. And I found a super interesting position at KTH and applied for it, and happy to say I got the job. So I am doing a PhD in threat modeling for digitalized power systems. And I thought, what could go wrong? It's IT security, and it's also power systems, which was completely new to me, but I knew that they had some challenges. In my past roles, I had spoken to some people in this industry, and they basically said, why do we need security? I mean, it's a separate network. And then you go, oh, not really. And we have seen a lot of attacks where they go through the corporate network and then into the actual OT, the operations technologies network. I would like to cover these 3 different topics. I was also happy to see a lot of introduction of threat modeling from Nadia. I don't have to cover that as much. It's sort of what you just have to include as well when you're in the academics. You need to have the related work background sections. Happy I can just sort of skip through that a little bit. Then I want to talk about cybersecurity threats against digitalized power systems. So what is special with these systems? What threats are we seeing and why? Finally, what are we doing at my department at KTH? What is our research group currently working on? Our research group is called the Software Systems Architecture and Security Research Group. It is quite a broad name, so I'll cover some different parts. If you have any questions or comments throughout, you can just raise your hand. I'll be happy to pause the presentation. Right. There was some consensus here as well. We've already heard about Stride and past that today, so I'm not going to go too much into this. But I think it's interesting because we try and get into the bottom of things as researchers. And I had a colleague that said, what is threat modeling? What is the actual definition? What are we saying in the research community? They did not come up with an answer. I was reading their paper again now before this talk to see like, what did they actually come up with? Can I give a good definition? This is threat modeling. They just gave maybe 10 different versions. Like, this is what researchers are saying, but there is no real definition. It's just about finding out what kind of threats are there to your system. What threats are more or less likely to happen and which threats are more or less severe. So yeah, it's a very broad definition, and Stride and PASTA are just 2 different approaches of how to do threat modeling. The attack tree is interesting, and this is where I focus most of my research. Yes?
Sorry to interrupt you. I have a question here. So as you said, like you are doing the research on these threat modelings, there are already a lot of methodologies to do the threat modeling, like Stride and Pasta, and there are more even. Some of them are quite old, some of them are probably new. But are you going to research or invent something new when it comes to threat modeling methodologies? As you are doing the research and combining probably all these methodologies, maybe you can find something which, because when it comes to threat modeling, it's uh, it takes time. I mean, it evolves. As you do these things, it will be more granular by the time. But I mean, it's also a complex thing to do the threat modeling, because when you are going to run your application on premise, you have to think in that way. But when you have to run the application on the cloud, then it's a different thing. So how you are going to do these same type methodologies applied to the on-premise applications and also to the applications running on the public cloud like Google, Oracle, IBM, or like maybe AWS. So, and especially, I mean, we know like there are challenges when it comes to banks. So, I mean, the conclusion is like how we can use the same threat modeling methodologies in the different environments, and how we can apply those things irrespective of the environment.
That's a great question. And we have our own methodology that we're using in this research group. We create a meta attack language of a system, which means that we describe what the system could potentially look like with language. So we say that there might be computers, there might be routers, etc. And then you build models, and then you can automatically generate attack graphs from these models. So that's the specific methodology that we are using. And some of the professors at the department, they branched out and built their own company that created a software for this. And there was even somebody here today that used to work at Klarna, and they tried this software at Klarna, which of course, as you know, is a bank. And yeah, so this is what we're seeing. We're seeing more automation happening. So we don't have to rely only on that brainstorming sessions. But as much as we can automate as possible is great. And the same something Akka did in her thesis. Very similar. You use a configuration file, and then you automatically build your model from that. And then you literally just press simulate, and you get your attack graph. It's a great question. Does that answer it? Perfect. Was there any more questions? No. Great. Right, attack graphs, commonly attributed to Bruce Schneider. He wrote an article about this in 1999. And usually we talk about him as sort of the founder of this idea of the attack tree, which then developed into an attack graph that just keeps growing and growing and growing, like Nadia was saying. We try and simplify the way security looks for a system by using these trees. So you start from the bottom, you have your different first ways into the system. Maybe you find a vulnerability. You may also need a network access, so you can have and or branches. You might need a lot of different paths, solve a lot of different vulnerabilities in order to move further up the tree. Finally, as in my case with my research, the most critical thing, the main goal, is a power outage. This is what you want to achieve as an attacker. I created this attack graph of one of the most famous attacks that happened in Ukraine a couple of years ago. They had some substations shut down for a couple of hours in the middle of winter, which was catastrophical. And this is really one of the first real examples that were written about in the media. I'm sure you all come across this in your jobs. It's not like you get attacked and then you want to spread it to the whole world that you've been attacked. It is changing, I think, more and more the mentality you want to share when you've been attacked. But tricky with this research is that most companies don't want to tell you when something has gone wrong. In any case, this is a good example to show how an attack graph looks like in the real world. Was there a question?
As you said, there's sometimes not a lot of publicity on attacks, and especially successful attacks. Where do you find it? Like, if you want to read up about it, where would you find it?
Yeah, I think that summarizes my PhD. Where do I find this information? It is difficult to find it, but there are, of course, if you would Google, there are some sources. But it is really difficult. In my research, when I try and gather information, I'll talk about this more, but when I try and gather information about attacks so I can build these models, you almost have to rely on other researchers that have just run pen testing and some things like that.
Thanks.
Another question.
It feels like someone has to do a research on finding research sources.
I actually did a paper on that.
Anonymized data for others.
Yeah, it's an idea we've talked about in the department. If you would go to all of these main energy companies and say, what problems have you had? Where have you been attacked? And so on, and just gather this information. That would be really cool to see the result. In threat modeling, we want to know these things. What are the vulnerabilities? We want to know the different attack steps. So how could an attacker move throughout the system? How is everything connected? And what is the likelihood of an attack? Because of course we don't have infinite money and the resources to make sure that we're secure. So we need to find out where is the most risk. And then we're also interested in the time taken for the attack. We talk a lot about time to compromise and in the research community to find out how long it would actually take, so we know how long we have to protect against it. And when I started my PhD, I was looking at these things and I was thinking, how do we know this? And we were talking about this a bit earlier, like you can't really go to a company and ask them to share all of their deepest secrets and all of their hidden attacks that's happened. So I wrote a paper and did a systematic literature review on this to find out what are my fellow colleagues doing? How did they actually create these threat models? This is super different from what Nadia is doing in her, or did in her job when they actually created threat models. Because as a researcher, I don't really have that privilege. But I found out that most people are using expert knowledge, previous research, or looking at these vulnerability scoring in databases. Because again, we usually get attacked with the things that are already known. You know you should have a better password, for example. You know you should say, yes, Windows, please update my computer. But you don't, and then you get hacked. So to talk a little bit about what has become my new passion, cybersecurity threats against digitalized power systems. This is interesting to me. Since at least March 2016, Russian government cyber actors targeted government entities and multiple US critical infrastructure sectors. Now, the US is just publishing this on the web. They're saying, we know they're inside. We know they can press a button if they want to. This is the new reality. This is cyber warfare. And I find it, maybe exciting is the wrong word, but it's interesting that we see all of these supermassive attacks that are happening, but we're not really even aware of them. And what is the difference between bombing a substation and attacking it to shut it down? And of course, the bomb we would all react on, that's crazy. But these things we just say, yeah, they're in our systems. They can control our critical infrastructure. So what is happening with these digitalized power systems, and why is it such a big shift? And why is the industry sort of lagging behind a little bit when it comes to security? One of the main things is remote management. Of course, this can be very remote places. Sweden is a very long country. We don't want to go all the way up to, I don't know, Överkalix to check on a substation. We just want to sit maybe down here in Stockholm and see on a computer. We also have increased visibility. We have sensors everywhere now. We want to know what is going on. We want to see when the voltage is increasing even before it breaks down, right? So we can do something about it. And Internet of Everything. Now you have an iPad when you go out on site. You have IP cameras. And these are connected to the internet as well, and connected to your substation network. I had the reference group that I used to discuss with the research I was doing to see how did it actually link to reality. And one of the biggest concerns there was this IoT. So we are using now IP cameras in our substations and everything is so fancy and digitalized and automated. But what is the danger? Remote exploitation. You don't have to now rely on somebody picking up a USB stick on the parking lot, taking it in and plugging it in. You have access now via the internet. Of course, increased attack surfaces, many more points of vulnerability here. And zero-day attacks. Let's not get into that again. Zero-day attacks, I think for the power systems domain, this is coming because there are so many solutions now being built in people's basements that then they sell, like smart little nifty gadgets. And these are not maybe as controlled and have gone through these rigorous pass-test ride processes of the big corporations. So I think this is an increased risk for zero-day attacks. So to summarize a little bit, the industrial control systems, they are getting more and more complex, and it's more and more difficult to know where are the vulnerabilities lying here. We also see that the number of vulnerabilities are increasing rapidly. And this is where threat modeling is so useful for ICS, because you can create a model of your system, run simulations, and find out what could potentially happen. It is good also, of course, to sit down and do brainstorming sessions, but how do you make sure that you cover everything? So I think it's good to automate as much as possible here. This is also one of those slides to show that there are cyber attacks happening. All the way from 1982, there has been attacks in the ICS industry. Now, this article was written in 2016, so it ends in 2015. But there are really more and more attacks happening. And I know I said there's not much information out there, but the headlines are out there. You can read about it every few weeks. There is something being penetrated, there's something being shut down. But what about the details? That's what we want to know, right? How did it actually happen? And that information is difficult to get by. So the substation automation system, to give you an idea, if you're not familiar with how they look like, the vulnerabilities are everywhere. On the right-hand side, you see what is connected to the normal internet, normal Ethernet. You have your smart meters at home. This is a big topic. These are very easy to hack. People are adjusting them to get cheaper energy bills. There's also, of course, an office network, the corporate network. You have the HMI that you're sitting at a desk instead of being out on site. Now, inside the substation automation system, you have a lot of different protocols, a lot of different components. In these industries, you might have something sitting in place for 30, 40 years and not being replaced. And even though they're trying to digitalize, it's sort of like, oh, but this is working, so let's just add some things on top of it, which is not the best approach when it comes to security. The vulnerabilities really lie everywhere. You can all the way down to the process bus layer where you have your circuit breakers. There are vulnerabilities. And the circuit breaker is the physical component that actually opens and closes the circuit, so you get electricity or not. Now, these circuit breakers are now being integrated with smart devices. Perfect, because we can see so much, we know exactly what's happening, we can automate it, we can see it from afar, but also super dangerous. Now, this is becoming like a doomsday talk. Sorry about that. Okay, final topic I wanted to cover. What are we doing more in my department? And this is also what Akka was working on when she was working with us. This is our main approach. We use something called meta-attack language. On the left-hand side, you will see a meta-attack language specification. And here is how you write out what your system looks like. You would have all of your assets. You will have all of your different attack steps, all of your defenses, and how you would move through those different attacks. You move through them by associations. So this is the trickiest part of it, to define your language. Once you have that, you can just build your model based on what your system looks like right now, or maybe what you want to look at specifically at the time. And then it automatically generates an attack graph. So as I said, this was a framework developed by some professors at the university. They just got sold to Google, so now they're being integrated there. But I know that there's been a lot of testings out in the industry to make sure that it's useful. Okay, yeah, one question.
Name there, Pontus Johnson. Is that the head of Sweden's cyber?
Exactly, yeah. Was that? That was okay.
The same guy.
Yeah, no. Pontus Johnson is a little bit of a celebrity right now. I think he's all over the news. He has started to build at Gate Age also these cyber soldiers, and we're teaching them about threat modeling as well.
All right. Is he still a professor at?
Yeah,
yeah,
definitely. Was there anything else that somebody was wondering now? Yep.
So this meta attack language that you are developing probably. I think this also involve a learning curve, right?
It's involved what?
Learning curve. I mean, I have to learn in this language as a syntax and everything, or how it is. Is this a language like the Java, Python, .NET that we have to?
Yeah.
So isn't it like some extra thing that, or who is going to do this? I mean, is it business people or developers working in organization? They are going to write this language or frame. I mean, anything for doing this threat modeling. So I mean, and also I looked into your previous slide. So the syntax is not same as .NET and other, but it's totally different. So for like, if someone will say like, okay, I have to do this threat modeling for our applications, then if I go toward this language, meta attack language that you guys are developing, so that means like I also have to learn this. Or the developer or the business people who is going to do this, or the software architects, they also have to learn these things. So but there are other methodologies which doesn't have this language, like pasta, stride, and all those things. It's just like theoretical concepts how you're going to model your threat, I mean, design the threat modeling for your applications. So what do you think about this? I mean, you're doing something which is also demanding some learning. And threat modeling is itself is a learning curve. You can't get everything right in one go. It evolves. So I mean, that is my question, like basically, like, I mean, if I want to use this meta attack language, that means like, okay, I have to learn this first of all, and I don't want to do that because I'm probably doing learning a lot of other stuff like Java, .NET, Python. Why am I going to learn this thing rather than using this pasta, stride, or other methodologies available in the market already?
Yeah. And so for the idea is that a developer would create the language itself, and you as a user would just have to drag the boxes. You just build your system. So you wouldn't have to get into the nitty-gritty language of itself. Yeah, then you would have to talk to the developer that creates the language. And this is coming from the research community. We're not trying to create products for the industry to use. It sounds maybe weird to say. For CT, this company that they created, for them, there's a built-in language already. You have that. If you want to make changes, you talk to the developers. But as researchers, it's a good question, but sort of getting into the nitty-gritty language, that's what we want to do. So we're happy to see other researchers that also want to make changes to the language and develop it further. But I see your point. For usability perspective, it's not great, no. Yeah, you're more than welcome. And reach out to me if you want to help to get started. But also when it comes to stride and pasta and these methodologies, you would still have some process to find the attacks and the assets for your system.
As a comment, you need to learn in general everything, and you want things like this to automate because there are a lot of threats, so you don't want to do it manually. It's like asking, well, I need to learn Terraform to create infrastructure. I'm like, yes, but do you want to click in the cloud to create every single server? You don't. So you do the learning in order to actually gain the benefits on the long run, not in the short run.
A quick question. Is this language can be connected to the OTX, which is Open Threat Exchange? Like I can use it to exchange the threat with other.
It's not automatically connected, no.
Oh, okay. Cool.
There is the Mitre attack. I don't know if you've heard of it. Is that what you were referring to? There is some big colleagues of mine in the department, they created a language called Corlang, and they use all of the Mitre attacks to build into it. Yeah. So then you would just use that and you have all of those different attacks already there. Okay, great. I wanted to show also a threat model I did for a language called Saslang. And here I also used the Mitre, but the ICS part of it. This is an example of a man-in-the-middle attack. I'm not going to go into too much, but you create your system and then you hit generate and you get this nice attack path. And you would see a lot of different attack paths that could potentially go through the system. This is a simple example, but you would also find out the time to compromise of the different steps. If you want to, you can also add defenses so you make it more aligned to what your system actually looks like. Okay, this is one of the last topics of what we're doing in research, the time to compromise. McQueen et al., they started this topic back in 2006, and I found it super interesting. So they have an equation of actually calculating time to compromise, because I'm sure that you've also come across this before. You're thinking, okay, but we have this vulnerability on this component, but how long would it take? Like, do we have days? Is it minutes? Is it years? So I thought it was super cool to find somebody that created an equation for this. So I did a paper where I updated their version and made it ICS specific. And I used the same Mitre attack as we already discussed and calculated some time to compromise for these different types of attacks. The Mitre attack is a knowledge base. It is a community that's gone together and said, these are all the different attacks that could happen. And these are the different effects of these attacks, to try and just collect it all in one place. If you haven't seen it already, you should definitely check it out. And it's nice to see this on paper. You have the time to compromise. It's 3,594 days. Of course, take it with a grain of salt. It's also for different types of attackers. And I know we haven't even touched on this today, but this is also a massive topic. The big difference between a script kiddie and somebody that is hired by a government to hack, you can't even compare it. You can see here there's a big difference. So for the HMI, for example, there is a higher time to compromise, lower time to compromise compared to protection systems. And then you can sort of go back and forth and discuss why this is the case. Like we do in research. We don't really provide results. We just say, could be like this, maybe. This is my final slide. I wanted to give you a tip before I leave you. We have an ethical hacking course at KTH, and Pontus Jonsson is the professor of this course. So what you do here is you capture the flag. Have you done capture the flag challenges, somebody? Yeah. So if you find those interesting, you're going to really like this course. You can either do it as a normal KTH academic course, but there's also a contract teaching one. So if you're working, you can ask your employer if you can do it as part of your job. I'm one of the teaching assistants in it, so if you start with the course, you can just reach out to me and I might help you. And that was everything for me. Thank you so much.